Hello there, my name is Ana Valdivia and my partner and I are going to talk about how amplitude affects wave speed.
Hi guys, I'm her partner Skylar Thompson and I'm going to tell you about the purpose of our lab. So the purpose of our lab is to demonstrate how to calculate wave speed and how changing amplitude of the wave affects the speed of the wave.
To continue our lesson and lab, we have to go over some important terms. So right here we have the waves. At the top of the wave it's called the crest and the bottom of the wave is called the trough. The amplitude is the height from the crest or trough to the center of the wave, which is demonstrated here by the dotted lines. Transverse waves are waves that travel at right angles or perpendicular towards its movement. This is considered a transverse wave. The frequency, that's also determined with the letter F, is the movement of an object in a specific time frame. The movement is also known as vibrations. If you grab a pencil and you draw a squiggly line, from one end to the other is one vibration. The wavelength is also described by this variable is the distance from one peak to the next. So from one crest to the next crest or one trough to the next trough. The wave speed is calculated by using this equation. So the wave speed equals the wavelength times the frequency.
Hello there, so like we were saying before, in order to calculate the wave speed, we must use this equation, V equals lambda times F, which is the wavelength times the frequency. But luckily for us, there is another equation that we can use to find the wave speed. And that is V equals G over T, which is the distance divided by time. And for the purpose of this lab, we will be using this equation, where we have the distance and time. So before we start the procedure, I want you to make a data table. Our data table is going to be a 4x4 table where we have the amplitude on the left measured in meters, the distance also measured in meters, the time which is measured in seconds, and the wave speed which is meters per second. In this lab, you will learn how to calculate wave speed and also how amplitude affects the wave speed. The materials needed in this lab include a ruler, slinky, tape, timer, data table, pencil, paper, and a calculator.
Before we get into our lab, let's do an overview of our procedure. So first we're going to make a data table, which we already did. You filled in all your columns and stuff, and that's good. Second, we're going to clamp one side of the slinky down on the table on a flat surface, and then leave the loose end. Third, you're going to take the distance and measure the whole slinky stretched out, and that's going to be your distance for each of the columns in the triangles. Then you're going to change the amplitude of your slinky by putting tape on one side of the table, and then you're going to add increments of 0.20 meters. So you're going to start at 0, and then your next one's going to be at 0.20, and your next one's going to be at 0.40, and that's going to be your 3 trials. Then you're going to measure the time it takes for you to get the slinky from the starting point to the amplitude point that you desire and back to the starting point. And that's going to be your wave, your frequency. So that's going to tell you how much time it took to get from one point to the next point. You're going to do a trial for each of your 3 increments, and then you're going to see the times, and then we're going to calculate the wave speed.
Okay, so after you make your data table and clamp one side of the slinky, you want to stretch it all the way out and then measure it. So for this, we have exactly 1.5 meters, and then you want to write that down in your data table for your distance for all 3 trials. So now that you measured the distance, you want to make sure that you write it down on your data table. So it's 1.5, and everything is measured in meters for the purpose of this lab.
We already pre-measured our tapes out, right? So we start off with 0. So one increment will be 0.20 plus 0, which goes 0.20 meters for our amplitude. Our second trial, 0.20 plus 0.20, goes 0.40 for our second starting point. And our third trial, 0.20 plus 0.20 plus 0.20, because 0.60 meters for our third trial. And here's your data table. So, as you see, we'll start the lab. My partner is now fully extended the slinky. She has started at our starting point, which is 0.0 meters. She's going to time from when the timer goes to our first trial, 0.20, and back, and stop the timer. She's going to release the slinky and put the time on a data table. This time will represent how long it took the slinky to go from 0.0 to 0.20 meters and back while stopping completely. As you see, she has gotten 1.90 seconds. For trial 2, she will go to 0.40 and back to the original starting point. Stop the time when the slinky stops. and she will follow the time down in your second trial for time 2. As you see, she has gotten 2.15 seconds. So now my partner is going to go to 0.60 meters for this trial 3. She's going to go 0.60 and all the way back and stop the timer when the slinky stops. Release the slinky and put the time on our data table in trial 3 for the time. So as you see, she has gotten 2.75 seconds. So if you guys had any trouble following any part of our lab, you can always reference back to the procedure shown here.
Now all we have left to do is find the wave speed, and in order to do that, we must use this equation we have mentioned previously, which is v equals d over t, which is the wave speed, equals distance over time. So for our first trial, we would do 1.5 meters divided by 1.9 seconds, and we get 0.789. For the purpose of this lab, we are rounding to 3 decimals. The second one, you do 1.5 divided by 2.15, and you get 0.98. No, 0.698. Sorry. Make sure you write meters per second. Then you do 1.5 divided by 2.75, and you get 0.545 meters per second. So by using this equation, you're able to find the wave speed when you are given the distance and time. What did we learn in this lab? First, we learned how to calculate wave speed, and in order to do that, you must use this equation. V equals d over t, which is distance divided by time. For the purpose of our lab, we use this equation instead of the other equation we provided before. And our distance was the same. So how does amplitude affect wave speed? As the distance stayed the same and our time increased, when we changed each amplitude, that lowered the wave speed. So that means the more amplitude you have, the lower your wave speed is going to be. It's only if the distance stays the same. It also happens vice versa. For example, if the amplitude decreases, then the wave speed will increase.
So guys, I hope you guys learned a lot in this lab, and you learned how to calculate your wave speed and your amplitude, right? So when you ride the waves, you'll know what speed you're going. Thanks. See you later. Bye.
Bye.